Question 3, here we go. The graph of f is shown above for 0 is less than or equal to x and x is less than or equal to 4. What is the value of the integral of 0 to 4 for f of x dx? Okay guys, so the first thing you should notice is that we have two lines here, which means that this is going to be a piecewise function. So because it's a piecewise function, we're going to have to split this integral into two parts. So let's go ahead and figure out what those two parts are. So let's go ahead and figure out what the equation of these two lines should be. So right here, for this line right here, I already see that we have a y-intercept of 1. So that point right there is going to be 0, 1. So using the form y equals mx plus b, I already know that y has to equal mx plus 1, right? Okay, now as far as the slope goes, you should remember that slope is going to be y2 minus y1 over x2 minus x1. So my second y value is going to be 5, and my first y value is 1. So I'm going to have 5 minus 1, and then that's going to be divided by 2 minus 0. So what's going to happen is this is going to simplify down to 4 over 2, which is just 2. So now I know that my first function is y equals 2x plus 1. Okay, awesome. Now, the other thing I want to figure out is what is the equation of this line right here? And because it's a horizontal straight line, I know that this is just going to be y equals whatever this point is right here. So we have -1, -2, -3, or not point, but really whatever that y value is. So the y value is going to be -3, therefore we have y equals -3. So now I want to essentially splice these two lines together and make a piecewise function. So I'm going to go ahead and write out the correct form. So now I have that f of x, I should say f of x is defined as, those three lines just mean defined as, because we're essentially having to define the piecewise function. So I'm going to have 2x plus 1, it's defined as 2x plus 1 from 0 to 2. You see how this is filled in? So that is the domain of this function right here. So it's going to be whenever x is greater than or equal to 0, and whenever it's less than or equal to 2, this function holds true. And then the last one, -3, we can see that that is true whenever x is greater than 2, but less than or equal to 4. Okay, so now that I have that, I just need to write an integral that splices these two functions together. So what I'll do is I'll say, all right, well, the integral of 0 to 4 for f of x dx, well, that's just going to be equal to the integral of 0 to 2, 2x plus 1 dx. Then I have to add the second half of it, which is going to be 2 to 4, -3 dx. Now, whenever I compute these two integrals, I can go ahead and simplify it down, and I'm going to get, let's see here, x squared plus x, right, evaluated from 0 to 2, plus the integral of, or not the integral, I should say -3x evaluated from 2 to 4. All right, so let me go ahead and clear some space, and then this is just a very simple evaluation here. So the first one is just going to be 2 squared plus 2, and then minus 0, because whenever you plug in 0 for these two values, you just get 0, right? So I'm going to have 6 here, equals 6, and then I have to add this part right here. So I'm going to have -3 times 4 minus -3 times 2. And let me go ahead and get that cleaned up a little bit. Okay, so I'm going to have 6 plus -12 plus, because the minus minus, 6. Now, whenever I go ahead and compute these values, what will I get? Well, 6 plus 6 is 12, and 12 minus 12 is just 0. So the correct answer is actually going to be 0. So yeah, a few steps here. I'm sure some of you could have just probably looked at the functions and just kind of computed the area under the curve. But I think this is a good kind of rigorous way to understand how to set the piecewise function and then solve it. So yeah, that's the correct answer. If you have any questions, feel free to comment below, and I'll see you for question number 4.